our third topic or third unit, that is over the CNC, that is CAM part. So we have seen the theoretical parts, what is NC machines, advantage of CNC machines over the NC machines, uh, what are the difference and in that, what are the parts involved in the NC machines, CNC machines. Then what are the adaptive controls, open loop control system and closed loop control systems, which is given to the MCU machine control unit. And then we have seen the DNC, that is a direct numerical distributed numerical control. So in that, these two will be asked for the short notes, in which distributed numerical control is the one machine from which we can control a number of CNC machines. Suppose assembly line is there and various operations to be performed on the cylinder block. Some having having a bore machine, boring of that cylinder. One having a another operations, drilling operations, then surface finishing operations are there. Then the coding part programming will be distributed by this DNC control system, and to that CNC particular system by dripping method of the programming. So that is the advantage of this DNC. So today we are going to start the finite element method. So it is also called as finite element analysis. So in this topic, we will discuss about the introductory part, what is the FEM or FEA, and then what are the types of elements are involved in that, what are interpolation functions, what are the shape functions, okay, so, and what are the boundary conditions, then what is the machine, nodal displacement, and problems over 1D, 2D, and 3D problems, that is axisymmetrical problems and all. And also it involves the dynamic and thermal analysis for particular wall section. Okay, and what are the steps involved in this APM we will see. So starting with the first, that is the introductory part of this. So in this, so what is FEM or FEA? So it is a finite element analysis, a numerical technique for finding an approximate solution, not an exact solution. There are two types of solutions: are there approximate solution and the exact solution. That is, approximate solution is much nearer to the exact solution by using the partial differential equation. So in this, for this topic, we don't have that, or is uh, means different partial differential equation problems are not there for you. Only application problems are there in this syllabus. Okay, so there are different weighted residual, then relay rate method, then Darlican method is there for this partial differential, that is involved in the FEM project. Okay, so in this unit you have to just the application based topic is in this CAD CAM. So in this on this topic, 2 to 3 problems will be asked. That is either one problem, 1D element problem, and one 2D element problem. One problem is over 1D element and one power or on 2D element. And additional to this, they will ask you heat transfer problem. Okay, so there might be chances of 3 problems on this unit. So we have to cover that. Okay, so in this APM method, the CAD model or the part which is to be analyzed is to be tested over by using this FEM analysis. So in this, dividing the part or the model, suppose it is a complicated problem is there, into a number of elements. Okay, so that might be different quadratic element, or it a hexahedral element or octahedral element. So dividing that, so how much you have matched that element part, more approximate result solution will be closer to the exact solution. Okay, so This is useful for solving geometries, loadings, and material properties, and analytical solutions like trace, trace, or displacements can be find out by using this method. Okay, so how does it works? So it works on so basically this interpolation function involves three types of analysis, that is simplex, complex, and the third one is the multiplex. So in your simplex problem, you have the 1D element problems. In complex, having the n nodes, element having only the n nodes, and in complex, the nodes are increased. Intermediate nodes are involved in that, and in multiplex, 3D parts and intermediates are involved in that. So I will show that what is the difference between simplex, complex, and multiplex also. Then after this, this FEA complex system uses nodes. So what are those nodes are? So nodes are nothing but I will draw it. So suppose a linear element is a step bar, and so if this is the element and this corner point ends are called as the nodes. So it has a two nodes. One element consists of two nodes. This is the element. Okay, this is the element. Okay, so we are considering a step bar of a certain length, and then this end points are called as the nodes, and the entire part is called as the element. You can divide that and into number of elements and shapes. Okay, so that are the nodes. So which makes a grid, which makes a grid. Suppose uh, okay, suppose this type of spring cut system is there, and this is fixed over here. So there are, you can see one, two, three, four elements, and forces are applied over there. So meshing means what? You can suppose a step bar is there, cantilever type, and you have to divide this. Discretization will be there, and you have to divide into number of nodes. One element can be divided into number of nodes and elements. Okay, so these elements are divided into number of nodes. This is called as meshing. Okay, there may be a manual meshing will be there, or it may consist of a map meshing or free meshing. So there are two types of meshing is called. One is called as free meshing, so in which triangular meshing, tetrahedral mesh are there, and in free meshing, and map meshing, quadratic meshing will be there. Okay. So next, this mesh program to be contain the material and the structure properties. We define the structure which react with the certain loading condition, that is called as the boundary condition. Then after giving the boundary condition, suppose forces is there on that element. If a tangential force is there, or a compressive force acting on a certain element, or a point load acting on it. So that is called as the boundary condition, or torque acting on that bar, suppose. Okay. So that are called as loading condition or a boundary condition. So after giving that uh, throughout material, depending upon the stress level of a particular area, it will show you the results. Okay, so after giving this boundary condition, we will go for the solving purpose. In that solving, we will define that all these boundary conditions and the machine of that model, and then in the post process we will get the result from it. Okay, so what are different types of analysis can be done in this FE? That structural analysis we can do. We can do thermal analysis of linear and nonlinear elements. Then vibrational analysis we can perform over this. Okay, so this is an example of a bridge. Okay, then a fatigue analysis, continuous load acting on a bridge. Bridge can be a example of the chest or and body. So okay, so that is a fatigue analysis. Then heat transfer analysis. So a simple example of thermal analysis and shell top heat exchanger. Okay, then so these are the areas in which dynamic analysis and static analysis are also are there. In that, thermal analysis is then in structural analysis, as well as in fatigue and vibration analysis. Then how can FEM help the designer, design engineer, is that before manufacturing, we can analyze that part, and then we can go for the manufacturing purpose. Suppose in this case, the FEM offers many important advantages. That is the easily applied to complex irregular shape objects composed of several different materials. So we can change the materials, we can change the design, thickness, and other criteria of that particular geometry. Then applicable to steady state as well as time dependent, time dependent means suppose a certain cyclic load is acting on an element, then you can analyze that. Okay, then linear and non-linear problems can also be solved by using every method. So these are some advantages over this, and it's include problems of solid mechanics, fluid, chemical, electromechanics. So if we are studying in this is the heat transfer, and then the solid mechanics and solid mechanics. Only two we are considering. Acoustics are not there. Okay, so. So how can the APM help to design any organization or any designer or for the optimization purpose? So it reduces the testing and redesigning of the cost. Okay, so as we are analyzing that part after creating the model, and we just take the results from it. So we can edit our design, and then we can go for the product manufacturing. So and it's also shorten the product development time also. So how it can shortening the product development time means in the past few decades, uh, first CAD is done, and then manufacturing is done, then testing are carried over that, and then it fails again, redesigning it, and again product developing. So this takes consumes more time. So this can be eliminated by using this analysis method. Okay, so and we can identify various issues in designs and tooling. Okay, and we can refine the components before going for dependencies on prohibit changes components, and then we can optimize the performance before prototyping also, prototyping of that particular product. Okay, and discover design problems before litigation. So if we launch that product and then after it gets failed, so various litigations can be arises at that time, that can be avoided by using this CAD method. So basic steps involved in this FEA is the first one is the discretization. Discretization involves also means meshing of that product. Then the selection of approximation functions, that is the interpolation function, whether it is a simplex, complex, or multiplex. Then formulation of element stiffness matrix. We will see in this solving the problem what are the element stiffness matrix used. So element stiffness matrix are used for different elements. It will vary with the 1D element, it will vary with the 2D element, and it also varies from the spring. Suppose it is a spring or a bar or trusses or a beam element is there. So depending upon that, formulations of stiffness matrix will be changed. Then you have to find out the total global matrix, stiffness matrix you have to find out, and then we have to formulate that with respect to the loading conditions, so that is bonding conditions, and then you have to find out the overall equilibrium equation from it, and then after implementation of boundary condition, we can calculate the nodal displacement, stresses and strain from it. So this is the total steps. So in this first discretization to this boundary condition are the pre-processing, and then solving will be there. Second step of this main FEA system, pre-processing, then solving and post-processing. In post-processing, we get the results from it. Okay. Then so this is the thing. Okay, so pre-processing is in which we can do the meshing, we can give the boundary condition to our problem, then we solve a solution second phase of that FE is there. In this phase, governing metrics are derived and solution for the primary quantity is generated. Suppose we consider the ANSYS software. So in that software, we will first define the various properties, which element you are going to use. Then geometry subdomains we will define. Then we will divide, we will perform the discretization by meshing operation. And then we will apply the boundary conditions over there. And we will take the involving various equations, matrix, governing matrix equation, Gaussian method equations, and all these equations are given. Depending upon what type of element you have choose, it will solve that problem in the second phase. And in the third phase, you get the validity of your solution. That is the what are the errors, are there displacement errors, stresses, strains, so all related to the results. Okay, depending upon which type of analysis, whether it is a structural analysis or a thermal analysis or other type of analysis. So what again it is repeated, that is it can be uh, solved in geometries. Okay, and on. Okay, so this is repeated. Limitations. We will see about the limitations. The FEM is applied to approximation result, so it is not an exact result. So in industries, they will use this ACA method, but they have to, suppose a car is there and a crash test is analyzed in a software. Still, they have to take the test, actual realistic test of that prototype. Okay, so to get the exact solution, what effect the product is facing in the real world. Then experience and judgments are needed to construct a good finite element model. So it requires expertise in that. And AFM softwares are it's reliable on the softwares. So so you have to purchase the software for a commercial purpose. It is very much essential to perform that analysis. And input and output data may be large and tedious to prepare and interpret. Okay, also. So all data should be accurate, right? So that the output results we get from that will be much closer to the exact solution. Then there might be a numerical error, significant digits. Rounding off is in the software. Okay, that very much occurs in the software. It will round off that by the methods used in the software. Okay, and in fluid elements with boundaries at infinity can be computed and treated by using boundary element and method. So in this fluid elements, uh, in this APF, it is treated as a bond element. Suppose the bottle is there, so pressure is applied over the boundary of that bottle, or tank is there, water tank is there, then also it is treated as the pressure acting on that the circumference of that particular geometry. Okay, so uh, so these are some limitations of APA. So these are the various softwares used for APA, that is ANSYS, Nastran, Patran. Okay, so in this LS Dyna, okay, Hypermesh for meshing purpose, Katia for creating the model for various modules and forms. Okay, so in our curriculum, we will see two softwares. That is for the structural analysis. We will see for solving 1D elements problems. We will see ANSYS software, and for the 3D, that is for CFD purpose. So we will use the MSC software, which is recently purchased by Apple. Okay, so on that we'll take some experiments over that. Okay, so let's begin with the first topic. This topic in this unit number 4, that is the 1D element analysis. So you see this syllabus. So you can see over that the introductory part. It consists of types of elements. So various types of elements, but I will explain that. At the interpolation point consists of three types of elements are there: simplex, complex and multiplex. So I will show you the difference with one single example. So suppose a simplex function of a link element, will say this is a simplex form in which two nodes are there. Then this is a simplex. This is a simplex part. Okay. Then in complex, what different intermediate nodes are involved in that. Number of nodes can be. So this is type of complex. And in multiplex, suppose this in this quadratic suppose that, and in that intermediate nodes will be involved. Okay, multiplex. So depending upon the complexity, these three types are divided. Interpolation functions are divided in there. So link element is there. So this simplex, suppose a triangular element is there. So it will be in this way. And in this complex, it will be having a intermediate nodes in between this. So this is a one entire element. This is also element, but it has a intermediate nodes. Okay. So the problems in this, we will see that. So on this topic mode and one problem on 2D. This is compulsory, they will ask. So in 1D element problems, there might be a bar, spring, trusses, or beam. So four types are there, types of problems they will ask on structural analysis. On structural analysis. In 2D, they will ask the plane space, plane strain problems. Okay, in structure. In thermal analysis, again 1D problems they will ask only over the 1D elements. And okay. And on 3D, only one type is that the axis symmetrical problems will be there. So they will rarely ask in the exams. So we'll start with the first type because this is the most easiest unit in your CAD CAM. So it requires more time because varieties of problems are there. Okay, so starting with the first type is a 1D element problem. So in that we are covering first is a string problem. Okay, so in this you can see over here a problem is there. So in this springs, there are four springs are there and forces acting over that at F2, F3, F4. F1 is nothing but the kind means at this point it is reacting over that. So reaction forces are these two, this one and this four. K2, K3 are the stiffness matrix. Stiffness is given 10 Newton per mm, 15 Newton, 25 Newton per mm, and 20 Newton per mm. And forces are 20 Newton and 50 Newton. Okay, for F2, F3, and F4. Okay, so in this, they have asked you to find out the nodal displacement. Nodal displacement means when this condition is there, so what will be the effect over these springs? Over these springs, what will be the displacement? Nodal displacement. They will ask you, or sometimes they will tell you just solve this problem. Okay, so at that time you have to solve the nodal displacements. So in this matrix methods. Okay, so in this you have to solve the nodal displacement and you have to balance the reaction forces, and you have to find out that it is equal to 0. Okay, so we'll start with this. So for this solving, there are steps, various steps involved for this solving. The first step, we'll go step by step. Okay. The first step is a nodal diagram. Okay, this is a solution. Okay. First step is you have to draw a nodal diagram of this problem. First, draw a nodal diagram. So what is the nodal diagram is that you have to defining the element and you have to define the nodes involved in this in the nodal diagram. So how to do this? So this is the first second, third, fourth, and five. So five nodes are known. How you can see this is the node number one. Okay, this is node number two where force is acting over there. Then node number three where F3 is acting with 3. Then F4 is acting with 4. And here when it is fixed over here is a 5. So total 5 nodes are there. And how many elements? 4 elements. 1, 2, 4. 4 elements with K1, K2, K3 and K4. Name the nodes 1, 2, 3, 4, 5. So first element is in between node number 1 and 2. Second element is in between 2 and 3. Third is 3, 4 and 4, 5. And these are fixed. These are fixed. So this is a nodal diagram. Okay. Then after drawing this nodal diagram, second step is to find out the element matrix equation. Element matrix equation. So element matrix equation for this spring element. For spring element. Okay, so K. So what is the equation for that? K 1 minus 1 minus 1 1. So this is nothing but suppose in the interpolation function a quadratic linear interpolation function, a quadratic equation is there. So a1 plus a2 a2x plus a3 y, okay, and plus a4 xy. So suppose this is one quadratic equation of this rectangle, okay, having 4 nodes. Okay, so if we consider this corners is divided, discretized into this, and eta and theta. Okay, so this way. So these 4 corners are first this corner is positive 1 1. Okay, this is 1 and minus 1. This is minus 1 and 1. So from this equation you have this has been find out. Okay, 1 1. So these corners, so in this way the tally of this, the tally of this, suppose I add this row, it will be 0. If I add this row, it will be 0. If I add this column, it will be 0. If I add this column, it will be 0. So all is balanced. So in this way, this matrix equation, so that is not for your syllabus. Okay, this all entire interpolation, the g theta, and this all is. So you have to just remember this matrix. So in this is the stiffness K. This is the stiffness matrix 1 minus 1 1 and 1. Then next one is U1, U2, U3, depending upon the number of elements. This is your means displacement. And last one is F1, F2, F3 will be there. So these are the forces acting on that element. Capital C is the stiffness, capital U is the displacement, and F is the forces. So this is the element matrix equation. It is called as the element matrix equation. So by using this, you have to find out element matrix first, then you have to find out the global matrix for that four elements. So there are how many elements are there? One, two, three, four. Four elements are there. So to find out this element, first for element number one, for element number one, okay, for element number one, what is the stiffness value? Newton mm. So in the place of this k, so k is multiplied in between. I will take this is k 10, 1 minus 1 minus 1 1. So I will directly take that as is equal to 10 minus 10 minus 10 and 10. Okay, and name this row and column 1 and 2, 1 and 2. Why 1 and 2? Because this element number 1 lies in between number 1 and 2. So I have drawn this 1 and 2, 1 and 2. Okay. Next for element number 2. For element number 2, I will directly write what is that stiffness value 15. So this will be, suppose I will write this k1 equal to small k1 equal to k2 equal to, so it is 15 minus 15 minus 15 15. Okay, so it is between 2 and 3, 2 and 3. So this element is in between node number 2 and 3, 2 and 3. So 2 and 3. For element number 3, k3 equal to how much value is that? 25. 25. So 25 minus 25 minus 25, 25. Okay. Next, for element number 4, I will write here element number 4, K4. So stiffness value is 20. So 20, and this is in between 3 and 4, 3 and 4. Node number minus 20, minus 20, and 20 minus 20 minus 20 and 20, and it is between 4 and 5, 4 and 5. So why to write this? You can see here find out the all element matrix equation for each elements. Okay, now for global stiffness matrix. Third step is a global stiffness matrix. So we are doing for getting capital K value. So for this capital global stiffness matrix. So how many nodes are there? 5 nodes. So your matrix will be 5 by 5 matrix. 5 by 5 matrix. Okay. So write down 1, 2, 3, 4, and 5. Again 1, 2, 3, 4, and 5. Okay. So 5 by 5 matrix. Now what I will show you how this will work. Okay. So now these are the values you have to write over here. Okay. So what values you have to write? Okay. So is on column number 1 and row number 1. So see, check that what is that value 1 year 1 and year 1. So it is 10. So here should be 10. Okay. this one over here and this one over here, where it is, what is the answer value? 10. We have to write down 10. Then again for second, 2 and 1, where it is 2 and 1, you can see over here, this is 2, this is 1, what is the, we have to write minus 10 in this way. Okay, so you have to refer the element stiffness matrix for each element to find out the global stiffness matrix. Now in one, whether we have the 3 and 1 combination, no, we don't have 3 and 1 combination, we have to write 0. Okay, then 4 and 1, we have it or not? No. 5 and 1, no. So right. Okay, then after 1 and 2, 1 and 2, this 1 and 2, what is that value? Minus 10. Write down the minus 10. Okay, then what is 2 and 2? 2 and 2, there are two values. Okay, this 2 and 2, 10, this 2 and 2, 15. So addition will be there. Okay, so it will become 25. 10 plus this 15. 10 plus this 15. 2 and 2 combination. Then 3 and 2 minus 15 we have. Okay, 4 and 2 is there? No, 0, 0. Whether we have 1 and 3? No. 2 and 3 is minus 15. 3 and 3, there are two values. This 15 and 3 and 3 and this 3 and 3, 25. So it's equal to 40. It's equal to 40. Addition of 15 plus 25, 40. Okay, then again 4 and 3, 4 and 3 minus 25. Minus 25. No, 0. Then 1 and 4 have it? No. 2 and 4? No. 3 and 4 we have it. 3 and 4. 3 and 4 minus 25. 4 and 4 we have 2 times. 4 and 4 this 25 and this 20. So 45. Next 5 and 4 we have it or not? 5 and 4 we have it minus 20. Okay. Next 1 and 5 no. 2 and 5 no. 3 and 5 no. 4 and 5 we have it. What is that? 4 and 5 minus 20. This one. 4 and 5 minus 20. Then 5 and 5 we have 20. Now you can see that we have in this equation, all the addition of column and row 0. So you can see over here. If we add this entire row, 10 minus 10, 0. Okay. If I add this entire column, it will be 0. If I add this in this one, second one also same, 0. All equal to 0. All the answers will be equal to 0. If we add any row and column, the answer will be equal to 0. So we have got the right global matrix balance equilibrium global matrix equation. Okay, so this is the value for K. This is the K value, capital K. Okay, this is capital K. Now this is the third, find out the global stiffness matrix. Find out the global stiffness matrix. Now next, after finding this, the fourth step is imposing or applying boundary condition. Boundary condition. So what are the boundary conditions? Nothing but this reaction force of by this two phase number 1 and 5 and this intermediate nodes F2, F2, F3 and F4 are the nodes, are the forces acting on that nodes. So these are the boundary conditions. So how to write that? You have to write the first that equation capital K into capital U, that is for displacement, into F, into F. Okay, that is the forces. So in this, the node number 1 and 5 are fixed. So node number 1 and 5 are fixed. So first we will rewrite this capital K values, all the values. Write it. 2, 3, 4, 5 for naming that row and column. You can directly write 10 minus 10, 0, 0, 0, minus 10, 25, minus 15, 0, 0, 0, minus 15, 40, minus 25. So next lecture you can solve with me by using calculator and all on the notebook, so that you get the practice of this. 45 minus 20 and minus 20, or otherwise it will be not easier to understand. Uh, while at the time of exam, you will forget how to find out that. So if you solve with me, you can get the hands-on experience on this, how to solve this numerical value of FEA. Then U1, U2 small, U1, U3, U5. How many nodes are there? 5 nodes. So the displacements might be 5 at the 5 nodes. Okay, and then you have to write F1, F1, F2, F3, F4, and F5. Okay, so now after imposing all this condition, you can see in this diagram also, there will, as the node number 1 at the node number 1 and 5 are fixed, there is no displacement. So conditions are, first condition is u1 equal to u5 equal to 0. So there is, as it is fixed, so there will be no displacement. Then forces given, F2 is given. Okay, then F3 is given, F3 is 20, F2 is minus 20. Why minus 20? F2 is minus 20 because left side forces are minus and the right side forces are positive. Okay. So in this way, compressive force, that's why it's 20 minus 20, F3 is 30 and F4 is 50. Okay, so this should be a negative one, which is compressive. Okay, so these are the condition, and F1 and F2, F1 equal to 0 and F5 equal to, so there will be no forces on that, so we have to take 0, 0, or you can write down, sorry, F1 and F5, you have to find out what are the forces due to the reaction. Okay, so we love this. So here I will put this value in this equation. U1 is 0 and U5 is 0. U5 is 0. Okay, so you have to find out U2, U3, and U4. So deflection or displacement at node number 2, node number 3, and node number 4. And what is this value? F2. F2 is minus 20, and this is 30, 30, and this is 50. F1. Okay, so in this way, we can use this equation, solve this equation. So after solving this, the first next step is the elimination method. Elimination. Okay, elimination method. So after by elimination method, by elimination method. So you have to rewrite this again, this matrix, this u1, u2, this values you have to rewrite again. So in this elimination method, what you have to do is that is fixed, whichever nodes are fixed, you have to cancel that row and column. You have to cancel that. Okay. So first and fifth, you have to cancel it. Okay. First and fifth, you have to cancel this column. It should be cancelled because there will be no depletion with that. Now we have to write down the equations. Okay? You have to framing the equation. So this is, you have to rewrite this again over here. Okay, and then you have to use this elimination. Okay, and then frame the equation. The next step. This is the step number 5, elimination method, and step number 6 will be framing of equation. Frame the equation after elimination. So minus 10, the first one is minus 10 into this U2. First row and first column multiplication. First row and first column multiplication. So this is cancelled out, so it's 0. The others are 0, so U3 and U4 will be not there. Only minus 10, I will write here, minus 10 U2, okay, minus 10 U2 equal to F1, okay. Okay, next equation will be 25 into this U2, 25 U2 minus 15 U3 equal to minus 20. This is equation number 1. This is 2. Okay. Third will be minus 15 U2 plus 40 U3 minus 25 U4 equal to 30. Equation number 3. Okay. Equation number 4, I will write here, minus 25 U3 plus 45 U4. Okay, as it is 0 over here, no U2. Okay, and equal to 50. And last, you write minus 20 U4 equal to equation number 4. This equal to F5. Equation number 5. Now, after solving this, you have to put this equation to find out first simply U2 and U3, where you can find out by manually or by you can use the calculator for this. Okay, and you will get the answers directly by putting that, converting that mode by this equation, and just put the values means 25, 15, and minus 20 in that table. So you will get the directly you get the answer in the calculator. Okay, so equal to, just search how to solve the equations by calculator. Fx your model number of your calculator in the YouTube, on YouTube. So you can use this instead of first manually solving. You can directly put two equations or 3 equations at a time, and you will get the values of this disbursement. So just search that YouTube videos, so you can get that how to solve that by this equation. So U2, I will directly write the answer after solving this. You will get U2 equal to 0.805 mm and U3 equal to. So from next lecture, I will ask the students to the answer for this 75 mm, and U4 will be randomly. I will ask the students. So what is the answer for this? You have to solve with me. Okay, 59 7 mm. Okay, in this way you can find out U2, U3, U4. Manually you can also you can solve this by first and 2 equation. You can use that and find U3 first. Then next use that U3 equation and then find out the second value from that. So in this way, manually also you can perform this. Okay, but it will consume more time. Okay. Next step we have find out this answer, that is displacements over the node number 2, 3, and 4. Now we have to balance the by using reaction forces. Last step 7, reaction force. So reaction, what are the reaction forces acting on that? Okay, so in that way you have to balance that. Okay, reaction forces. So for reaction forces, first you have to find out this F1 and F5 value, because in this equation F1 and F5 is not to find out. So for that F1, you can use this simple equation, this one and this, to solve by using this answer U2, U3, and U4 answer. So F1 will be minus 10 U2 multiplied with will get minus 8.05 Newton for F1, and F2 in this equation number 5, if we use that, we'll get minus 51.94 Newton. Now for balancing reaction forces, what is the equation for this? Summation of F equal to Fx equal to, because it is in x direction only, Fx equal to, it should be equal to F1 plus F2 plus F3 plus F4 plus F5. So addition of this, all these forces should be equal to, I think it will be 0.01. So that is equal to 0. If 0 point something is there, then you have to it is equal to 0, and hence our balance. Hence it is safe. Okay. In this way, the entire problem we have to solve by using this string card system. So in this we have steps. That is, first one is we have to draw the nodal diagram. We have to find the element matrix equations for each element. That is in this case 4 elements are there, and then we have to use that element matrix to find out the flow weakness matrix. And then after giving the boundary condition and elimination method, third, we have to frame the equation, and we have to solve the equation. We have to find out the displacement from that, and then lastly, we have to find out the reaction forces by adding all the forces. The problems are there. So in the next lecture, we will see this second problem, and after that, we will solve this in ANSYS, and we will check our answers are right or not. Okay, so that will be the directly application problem based learning we can see in the next lecture for tomorrow. Okay, so any questions regarding, you can ask me. Any questions? Are there any questions, or otherwise I will stop the session. We will see this problem, next problem tomorrow, and we will try to solve that in the ANSYS also. So whether we are getting the right answer by numerical methods, AFM method, or not. Okay. Any question? Rajapati? Are there any questions, or otherwise I will stop the session? Hello, Sonu Mishra. Are there any questions? What I will say? No, sir. So in the next lecture, you have to solve with, use your notebook to solve it, and a calculator is must required to solve. Okay, so that you will be understanding level, it will be much easier for you. Okay, so thanks for listening to the session. We'll meet tomorrow at the same time. Thank you.